Hi and welcome back to the lab. And today here on the bench we have an ICOM IC-7610 which is suffering from the real-time clock issue. Or with other words, the radio is constantly losing the time. And today we want to discuss one or two possible solutions how to get this issue under control. Okay, and let's look what I mean by saying losing the time. So let me switch on here our radio, and here on the upper display you see that here should be our clock, so our time, and you can easily see that okay, it just starts, and that is because the radio is losing the memory, and that is due to a little battery which is normally buffering, if you will, the memory of our clock. And yeah, let's go into that to see what it is all about. Okay, and we're looking here at the main unit, okay, and when I'm zooming in here, you see suddenly that there is a little battery, and this little battery is to hold, if you like, the clock, even if the transceiver is switched off. So that guy here is the little battery, and well, if the radio is switched completely off for a longer time, then this little battery gets completely drained. And if that happens more often, then of course sometimes this little battery is simply toasted. And that is what happens to many radios from this series. I mean, if that would be a commercial product, like for Marines or for avionic, for example, then those radio would run every single day, and this little battery get charged, right? So then I believe it is not a problem. But with a ham radio it is a little bit different, because it always depends how often the radio get used. So some of these radios will not get switched on every single day. Rather more, it stands for weeks maybe until it gets switched on again. And in the meantime, when the radio is completely disconnected from power, then of course the battery is needed to hold the clock data, right? And since this battery is quite little, it gets completely drained, and when it gets then connected back to the power supply, okay, it gets charged, but at a certain point these little batteries are broken and can't hold its load at all. And therefore we try to look for something different that we can. I mean, we cannot avoid that, you know, the circuitry is drawing some current. I mean, that is necessary to hold the clock. But we can do something here with the little battery. Okay, and that you understand a little better what I'm talking about. So that here is the data sheet of the little battery. So that is a ML414H, and as you can see here on the data sheet, it is a rechargeable coin type battery, and the issue is that when we go down here a little bit, so that is a 3 volt, which is well known, but that here is the issue. So the capacity of this battery is only 1 milliamp hour. And that, you know, is a little bit too small if you are using your unit not every single day. And having said that, so the question now is, what could be a solution? One solution, and of course there may be more than only one or two solutions, but that could be one approach to get the problem under control. So we could put, for instance, such a little battery holder somewhere here into the housing, and we take the old battery completely out, and with a holder like this here, you can easily replace the battery. And that definitely will help to extend the time until the battery is completely drained. Okay, but to understand what really the difference is, so that is simply a CR 2032, which is a well-known lithium coin cell battery. And the important point is that these batteries have 210 milliamp hours. And that means the capacitor of this lithium coin cell, the CR2032, is 210 times higher than what we have original in our radio. So that means that would extend the time with the factor 210, which is really a nice improvement of what we have today. Well, but of course there is a disadvantage if we do it with a kind of battery like this, because these batteries, especially the CR2032, is not rechargeable. And that means that we need to take some precautions that the CR2032 gets not charged by our circuitry, right? And simply, when we put here, let's say, our battery here to the housing, which might be one possibility, right? So we just glue it here to the housing, and then we do our connections here over to the board. Then that is fine, but as I said, we need to avoid that this battery get charged by the circuitry of our radio. So therefore, that is quite easy. We put a little diode here into our wires, simply to avoid that it get charged, and then the battery can only be drained. Of course, we should take a little Schottky diode simply to have a lower voltage drop. So that is all very easy, and that is what we are going to do here, because that is what the owner, so our operator, is so that is what he wished, and that is what he asked for, to make it possible to put a battery which can simply be swapped out if there is a problem. Okay, so that is one way, and that is what we definitely are gonna do here, and I will show you how we can do it. But another interesting point is that we could take, instead of the CR2032, we could simply choose here the ML2032, which is general spoken the same battery, cell, so no problem. But it is, as you can already see it here in the header. Let me see if I can enlarge it a little bit. So the ML2032, so that is a rechargeable battery. So that means the internal circuitry can easily recharge the battery while the radio gets operated. Well, maybe we would have to adjust a little bit the charging current, so that is something we have then to overthink, but in general that is definitely a nice way to do it, because then you have a long time not simply to think about the issue, even to swap out the battery if it is empty. So therefore, that is definitely another way to do it. These capacities are, you see, a little bit lower, but on the other hand, it gets charged, so it does not really need the 210 what we have seen from the CR type, right? So that is something you can decide by your own. But however, now let's go back here to our project, and here our owner told me he would really like to have the solution where he simply can swap out the CR2025, which is a smaller one, or the CR2032. More or less both the same battery, but with a different capacity. Now, what we have to do first is to hello, focus. What we need to do first is to take out here our little cell which we have in the radio, and you see that is a SMD cell which needs to get removed here from the radio, and that is a little bit tricky, because you might already see that we have a lot of tiny components very close to our battery, and of course we need hot air to get it off here, the PCB. And yeah, that is definitely a little tricky, and you can really do a lot of things wrong and destroy your radio. So if you decide to do a similar modification, be careful. So you really should be able to handle those SMD parts, and you will see in a sec that even I will do some precautions that nothing really can go wrong, because here is a little chip, and here the controllers are also very, very close, so we will be a little bit carefully not to destroy here anything. Okay, so you see I have covered here the board, and important as well is, can you see it? So I'm wearing here SMD protection, because that is important, not to damage something. So that is now what we need to do until we start. Now we prepare our microscope to get it all into a very good view, and then we can start the project. Okay, so we have it now here under the microscope, and what we do first, we try to flow some, let me call it normal solder, just to reduce a little bit the melting point, because here is always what is it, lead-free solder used, which has a higher melting point, and therefore we try to flow a little bit normal, or let it solder to it, simply to be able to reduce the melting temperature a little bit. So I'm preparing it here, as you can see, and next step will already be to put something to the joints here. Okay, so let's do our first step. You already see it is not easy here. But we will get it done. Oh, look. That is ground. So that always takes a little bit heat, as you can see. But I honestly hope that that will be fine, that we can go ahead with it. Okay, so now we can start with hot air. You see, I've put here additionally a metal protection. And now let's see how it works. You see, it is not easy going, but here we have it. Excellent. Okie doke. And of course, next step is that we clean here our board, so it looks quite nice. And I do not see any problems up to now. So the pads are already there by the look of it. Okay, let's clean it. Okay, that is good. Now, okie doke. Okay, so we have here some which we need to get rid. Other than that, everything is fine. Okay, so we can correct that maybe later, but basically, as far as I can see it, our board is completely intact, so no problem. Okay, so as you can see, the board is clean and everything is nice, so we can later connect there the wires which will run over to our CR2032. So that's fine so far. And now let's have a look on the little battery. So let's see what the voltage is. Okay, so here is our little battery, and I'm now really curious what the voltage, the remaining voltage is here on the cell. So let me go over to our meter. And let's see what the meter will report when I go down here to the little cell. Okay, let's go that way. So it is 630 millivolt DC, as you can see. So that is the rest from originally 3 volt, which is needed for our circuit. So we clearly can see that this, and it is dropping, as you can. It's increasing a little bit. So, well, that is normal behavior of a dead cell. Anyway, right. So let's go ahead with our project. Okay, so the owner wishes to get this tape kind of thing, which is detachable. Don't know if you can see the structure here. So we can put one side to the battery holder, and the other side goes to the radio, and that means that even the holder is detachable. But I think that might be really too big, too large. So I think we can cut it in half, and then we can put it down here so that we can put the battery in this location here. Okay, so let's try to cut it in half. I'm not sure how easy that works. Well, that is strong material and not quite easy, but we are getting through. Okay, and I believe that is quite good. That is quite good. No problem. No problem. Okay. Okay, so as already discussed, I have here a little Schottky diode, which has a lower voltage drop as the normal silicium one. So when I now go over here to our meter, and we're gonna test it out what we have. So you see the drop is 0.28 of a volt, which is lower as let's say 1N4148 or something like that. So therefore, of course, we take this little Schottky diode and put it then here to our directly to the battery holder, simply because when that is then connected here over the wire to the holder, and if then somebody would like to change the battery into rechargeable, then you easily can cut here the wire off and you connect it directly to the other pin, because we have here 2 positive pins, and that makes it very easy to change what you want to do. But now first we take, as discussed here, it with a little diode. Okay, so you see the diode here is soldered to our battery holder, and now we take here a shrinking tube, and we can put it over like so. Of course I have to cut it a little bit shorter, and then we can directly connect our wire to it, and everything is fine. Okay, so both is soldered together, and now we put here our shrinking tube over, and simply let's shrink it. Very nice. That's it. ready to go. Okay, so as you can see, we have already installed here our battery holder. Let me go a little bit closer, then you can see it down here, right? And it is nicely, it holds nicely in place over there, no problem. And what I've done now, I have connected here my test leads just to check if everything is fine when I'm going to put in the battery here. So let's take this here for instance. Let me put it in and you see very nice. So on the red we have the positive one and it is our 3 volt, and very good that we have used a Schottky diode which is really only dropping it for 200 mil. So that is really nice, and you see the battery fits here very nicely in. Yeah, everything is really good, and we can go ahead and finally solder now the leads here to our PCB. As you can see, the wires are connected to the solar joints, and important is, let me check here the blue wire, which is ground as you can hear, and we do not have a short to our red, so that is definitely nice. Now we are really almost ready. And for fixing here the wires on the board, the owner was asking for some hot glue just to make it a little bit more stable, and that is what we have done as well. Okay, so let's test. I mean, the battery which is in is a used one, so that is not crisp new, but anyways, we should see that the polarity is right, 2.99, so you see it is working, our circuit, and you see that we have another little voltage drop of 10 millivolt, so that is showing everything is working, and yeah, it is ready to go. Our project is finished, and you see everything is nice. Alright, so radio is working, and as you can see, the time has set now to the original time we have here, and everything is fine, ready. I hope that was interesting for you to solve maybe the same issue, and we are here at the end of our video, and thanks for watching. Catch you next time. Bye.